All right, so we gave the basic definitions about NFTs. Now let's talk about NFT issues. So here I list some issues from a paper that was published last year, I guess. So some of the issues are user authentication. One of them is identity verification and two-factor authentication. Other issues are listed as token minting, verifiability of token contracts, tampering with token metadata. I will explain all of them more in detail, by the way. Token listing, principle of least privilege, invalid catching, seller and collection verification, and finally, token trading, lack of transparency, fairness in bidding, royalty distribution, and marketplace fee evasion. So let's talk about all of these. Let's start with user authentication and identity verification. Major cryptocurrency exchanges enforce know your customer rules. They also enforce AML and CFT, which are anti-money laundering and combating the financing of terrorism measures. Because, I mean, they are regulated and these are the things you have to apply. But the thing is that NFT marketplaces currently do not enforce them. So NFTs are a nice way of having money laundering. So this is why it creates the spark initially, by the way. Two-factor authentication. Many NFTs marketplaces do not support two-factor authentication, and when it is supported, generally it is not enabled by default. So these are some problems. Also, if somebody do not create, for instance, a famous digital artist may not create an account at a marketplace, so somebody may impersonate that person and start selling NFTs if it is created by the original artist. This happened a lot in the past, so authentication is also a problem here. Yeah, token minting, verifiability of token contracts. A token contract is considered verifiable if its source code is submitted to Etherscan. So if the source code is not there, you might say that, okay, but the smart contract is already in the blockchain, right? I can download it and look at it. But the thing is that it is written in bytecode. So simple token contract, since the token contracts are complex, source code is much easier to audit than bytecode. Because from the bytecode, it is really hard to understand what the smart contract is doing. And there are many white hat hackers checking all of the smart contracts to see if there is a bug in there. And if there is a bug, if they can, get tokens, NFTs, without providing authorization, without having the correct private key, they actually get all of these NFTs and tokens to themselves, and then try to contact the owner and transfer them back in a secure way. So a lot of people lost a lot of tokens in this kind of non-verifiable smart contracts. Verifiability of an external token contract is crucial as they can be malicious or buggy. Malicious token contracts may not transfer the NFT after purchase. This happened in the past. You pay the money, but you don't receive the NFT. Buggy token contracts can burn gas without doing any real work. So assume that there is an infinite loop inside the smart contract. So you try to buy an NFT, pay the money, pay the gas, but your gas runs out and it doesn't do anything. The smart contract, exits the function. So there are many smart contracts with this kind of bugs. Around 28% of the token contracts are closed source. So you don't have the source code submitted to Etherscan. Between June and December 2021, OpenSea took down around 2,000 closed source tokens, which account for more than $300 million. Okay. None of the NFT marketplaces that support external token contracts mandate such contracts to be open source. So you can create your own smart contract in a closed way and start selling NFTs from these marketplaces. Okay. Tampering with token metadata. So as you can see, since we are creating an NFT and writing the metadata on the blockchain, it shouldn't be changed, right? If you can change the metadata, then they can change the NFT you bought, right? So nobody should be able to modify this metadata, but the metadata of a token holds the pointer to the corresponding asset. Hence, if the metadata changes, the token loses its significance. The ERC 721 standard for NFTs actually allows for the possibility to change a token's metadata. Changing the metadata violates the expectation of the buyer because it's no longer the thing you bought. So, creator or owner can change the metadata URL, actually, which stores the NFT you bought. So they can change the URL. Creator or owner can change the metadata itself. Even if changing the metadata is disallowed at the contract level, creator or owner can change it if it is hosted on web domains, right? If it is on an HTTP link, then you can change it anyway. So, in this paper, researchers observed that more than 100,000 out of 3 million metadata URLs were changed in 6 months. So, what they did was to create a bot. So they gathered and observed there are 3 million metadata, 3 million NFTs. So they recorded the metadata URLs. And from time to time, every day they check if the data changes. So during the 6 months, the bot observed that more than 100,000 of them change. So 100,000 NFTs are no longer the same at the time they were bought. Okay. Token listing is another problem. Principle of least privilege. Many NFT marketplaces use a single escrow account during listing. 100,000s of NFTs can be stolen if the private key of an escrow account leaks. So you are creating actually a single point of failure. So thousands of different artists create their NFTs, but you store all of those NFTs on a single account with a single private key. If that private key leaks, you lose all of them. Invalid caching, this is another issue. 4 out of 12 million NFTs on OpenSea are actually inaccessible because the IPFS or the HTTP link no longer works. The image is not there. You try to download it, but it is not there. But the problem is that 68% of these images are still cached because OpenSea not every time goes to the IPFS and downloads the image. They catch it. But once it disappears from the IPFS, the cached image stays there. This is why this creates an illusion that the asset linked to NFT is still alive. So you can go to OpenSea, buy the NFT, but it may not appear on your MetaMask as the image because it is no longer in the IPFS or other place. Another issue is seller and collection verification. Buyers have to verify the seller or the collection themselves. Again, if a famous artist does not have an account, you can impersonate them and start selling. So this is a huge problem. Lack of transparency in token trading. Some NFT marketplaces store sale records and transactions off-chain, making it impossible to verify any trace or the ownership history of an NFT. Because maybe you want to make a bid, they observe it, but instead of recording it, they may allow somebody else to make that bid, for instance, if it is not written on the chain. This is what it's saying. So there's no transparency if you are doing all of this stuff off the chain. So some marketplaces do all of the steps on the chain, but it is costly. Since you are writing to the chain, you have to pay transaction fees. Fairness in bidding. Some NFT marketplaces record bidding off-chain, which can be abused by the NFTM or the users. This is what I tried to explain just a minute ago. Royalty distribution and marketplace fee evasion. So this is important. So when you sell an NFT, so assume that you are the creator of that NFT. So you sell it and you earn some money, right? And marketplace also obtains some fee. So the person who bought it, they may sell it again. And then if they do, you still receive some money as the royalty fee because you are the creator of the art, okay? And also marketplace can get that some amount of fee. So this royalty fee, sometimes determined by the marketplace and it is fixed. And in some smart contracts on some marketplaces, you can determine by yourself. You can say it is 1% of the whole transaction or maybe 10%. It is up to you. But neither royalty nor marketplace fees are enforced in ERC 721 token contracts. and both can be avoided by a malicious seller. Moreover, OpenSea and Rarible allow the creator to modify royalty fee after sale. So this is a huge problem. So you sell an art saying that the royalties fee is 1%, saying that that person may sell it in the future and you will get only 1%. But after you sell it, you increase this fee and the new owner doesn't know this. They have to check. So around 9% of OpenSea royalty fees were modified after the first sale. So my favorite example by Moxie. So he wanted to show these kind of issues, the problems in the NFT standard by creating an NFT. So he created an NFT. And if you go to OpenSea and look at this NFT, it looks like this. But if you go to Rarible and look at the same NFT, it looks like this. So question is, if I buy it, how will it appear in my MetaMask, right? Because two different web pages show, marketplaces show it differently. So if you buy it, it looks like this on your MetaMask. Okay. So here's my example, and to show why this is an issue. So here, I mean, if you know how a web page works, Moxie does the following. So he put this NFT on his web page. So when he created the NFT, when he minted it, the URL goes to his web page. So you know that a web page is actually most of the time an Apache server. And when you want to download an image from a web server, you are actually making a request, right? You wanted to download using TCP communication, you're requesting a JPEG image. But since this is a server, you can just look at the IP of the person requesting this image. So if that IP belongs to OpenSea, Moxie's web page sends this image. And if it is Rarible, it sends this. And if it is MetaMask, it sends this. So since it is on the web page, even you can do the following. Just look at the country of origin. And depending on different countries, you can show different images, right? So this is a huge problem. And Moxie actually tried to show it in a very beautiful way. And funny thing is that when he tweeted this, and he wrote a blog post about this, OpenSea got angry and removed this image from their web page. So when you try to visit this NFT, actually you receive the 404 error or something like that. But the strange thing happened when OpenSea removed this image from their web page. This image in MetaMask also lost. So Moxie was surprised because it is like blocking Facebook in Turkey, but all of a sudden people in Germany cannot reach to Facebook, right? This is the same thing. So OpenSea actually removes this image from their web page, but your MetaMask also removes it. Here the problem is as follows. Since the data is on the blockchain, it should be accessible, right? So Moxie actually went to blockchain and realized that it's still there, so nothing happened. So question is then why MetaMask also removes everything OpenSea does? The thing is that MetaMask using a library that is generated by the OpenSea. So this is like looking at the world from other people's glasses, right? So using same API, same libraries, actually breaks this decentralization system. If you are relying on other people's source codes, libraries, and so on, then you lose the idea of blockchain anyway, because you turn this into a centralized system. So this example actually should be recorded as a historical example. So again, a lot of people still insist that when I give talks, they got angry, say that no, every pixel of the NFT image is stored in the blockchain. So let's see what is actually stored. So I created a digital art and created an NFT of it. Okay, so this is the NFT I created. So if you go to blockchain and look at this NFT, you will see this URL is stored on the blockchain. Okay, as I mentioned in the previous part, you actually request a token URI, and this is what you get. Okay, so as you can see, it is an IPFS link. This is the actual CID of this metadata JSON file. Okay, so at the IPFS, you have the JSON file. You download it, open the JSON file, and you realize that there are, as I mentioned, 3 fields: name and description. These are the things that the designer, the artist wrote there. But again, this is metadata, and in some marketplaces allow changing metadata. So here you are actually trusting the marketplace that they will not change this. But another thing I observe is that, as you can see, when I press the enter button here, it turns into an HTML code /n, right? So now the question arises, can I perform a code injection here and break the system, right? Because most probably most web pages will just take this description and print it on their web page. So actually you can do a lot of code injection and perform some attacks. So, I mean, I'm not encouraging you to do that, but somebody should check if you can do this kind of attacks by changing the description and see how the marketplaces or other web pages show the content. Okay, but then again, the image URL is now a JPEG image from here. So the image CID is here. Okay, so the problem is that this is the only thing is stored here, right? So what happens if this image got lost, right? In the future, I cannot claim that the image I bought was the one that I showed you in the previous slide. So some people argue that actually this CID contains the SHA-256 of the image. So initially I argued that the standard should have a hash field here showing the hash of the image. So this way in the future you can always claim by showing the image yourself and saying that the hashes are identical. So this was the thing I bought. So currently with this standard, you cannot do that. This is the main problem with this standard that I observed. So some people say that, but there is a hash value hidden inside this CID. So they are half correct. So let's look at this picture. And from this CID, you get this SHA-256 value. Of course, which hash algorithm you are going to use determined when you're first uploading it at the IPFS. Okay, you can use SHA-512. I think it even supports Blake or other hash functions, so you can store it in many different ways. But from the CID, I recovered the SHA-256 value. But the problem is that the SHA-256 of the file is this. They are not identical. So this is why I argue that this is not a good solution, because as I mentioned, this is not the hash of the file. It is the hash of probably the Merkle root. Again, I don't know because there's no white paper explaining how this hash value is calculated. So since there's no white paper, I went to source codes. I spent a few hours and I then said that, okay, I have more important things to do in my life, and I stopped searching it, okay? So I don't know what this hash value corresponds to, but it is not the hash of the image. But most probably, you know, IPFS divides this image into pieces. They take the hash of all of these pieces, create a Merkle tree, and this is most probably the Merkle root of it. This is my, you know, educated guess in this respect. But as you can see, since there is the hash of this image is not stored in the metadata, okay? So in the future, if people stop sharing this image in the IPFS, and if I don't have the original one, then I cannot re-upload it to IPFS, and this NFT got lost. This is why many NFTs got lost, as I mentioned in the previous slides.